In the next couple videos, we're going to look at a couple different examples. In this first video, we're going to look at a basic example where we just want to find the curl of some vector field. And so to make it even simpler, we're looking at a vector field defined in our Cartesian coordinates. So as we can see here, we have a is equal to x squared yz in our x direction and xz in our z direction. So we don't have a y component either. So in this case, if we wanted to find the curl of this vector a, we would go back to our equation for curl. And so that is equal to the partial with respect to y of our z component, which is xz, minus the partial with respect to z of our y component, which in this case is just 0. So that is in our x direction, plus now we have the partial with respect to z of our x component. So our x component is x squared yz minus the partial with respect to x of our z component, which is xz, and all of that is in our y direction, plus now we have the partial with respect to x of our y component, which again is 0 in this case, minus the partial with respect to y of our of our x component, which is x squared yz, and all of that is in our z direction. So of course we have several of these terms that are just going to 0 because our y component, so I guess just two of those are going to 0 because our y component is 0 in this case. So evaluating further from there, we have curl of a is equal to, so for that first term, the partial of xz with respect to y is 0 as well. So for that first one, we have 0 minus 0, so we're going to have nothing in our x direction. So then we have partial with respect to z of x squared yz is going to be x squared y, minus the partial with respect to x of xz is going to give us just z, so all of that is going to be in our y direction. And then plus, we have 0 from that first term, and then partial with respect to y of x squared yz is going to be minus x squared z in our z direction. So our final answer then would just be that the curl, so del cross a, is equal to, so in our x direction we have 0, in our y direction we have x squared y minus z, and in our z direction we have negative x squared z. So that's how we would use our equation to find the curl of a vector field.